Good evening, everybody. I'm pleased to introduce my friend and on and off collaborator, Professor Frido Smulders. Frido Smulders is Professor of Entrepreneurial Engineering by Design at the Faculty of Industrial Design Engineering and the Faculty of Technology, Policy and Management. In his previous life, he was an aerospace engineer and was part of the team from Delft that worked with Alcoa in Pittsburgh, my US hometown, to create Glare, an innovative aluminum glass fiber composite material with better mechanical property than alloyed aluminum. The material was first used for the nose cone of Airbus A380 and is used in many other aircrafts. He also spent 12 years as an industry consultant on innovation and product strategy. Currently, the emphasis of his research and education is on innovative and entrepreneurial behavior in social settings, in societies, companies, etc. And he's funded by Dutch government, EU, ministries from economics, education, and other agencies. In his living lab, Entrepreneurship by Design, Frido collaborates closely with industry for research as well as education. Following the lines of pragmatism, a philosophical stance, he aims to develop practice-relevant theory. Therefore, the living lab serves as an empirical base for his research as well as real-life context for his educational activities. I'll let Frido tell you about his work on research, education, and talent. Thank you, Frido.
Thank you, Sap. That was a wonderful introduction. What I prepared for you today is, I will start with introducing myself, but that Sap already did that. But I want to talk about how to educate entrepreneurial engineers, and then building on the last session, nouns, verbs, and adjectives. Okay. So I did aerospace engineering, as Sap already mentioned, and I focused indeed on the material that is in the fuselage of the Airbus A380. Basically, I was focusing on the predecessor of that, Aero, with Kevlar fiber in it, aramide fiber in it, and they had some trouble with it. So for my master graduation project, I studied the problems that they had with this new material, and proposed them to put a nanofiber in there, and that became a glass fiber, and that became Glare in the Airbus A380. After that, I worked as a management consultant in the field of innovation and creativity, but also technology, helping companies to think about strategically making strategic choices around technology. What will be dominant in the future? What can we work on? What are our capabilities in that sense? And for that purpose, you need creativity as well, as it is part of an innovation activities. I missed something in my practice, and therefore I returned to the university, but then to a different school, not aerospace engineering, but industrial design engineering, the faculty of I'm working on now. And I did my PhD in the innovation sciences. I don't know whether they are existing, but that's what I'm aiming at, innovation sciences, to build a scientific groundwork of what innovation or innovating as a human activity actually is. This is my PhD, the cover of my thesis for my PhD, which was a social sciences kind of approach. I used grounded theory, which is a social sciences research methodology. And in that, or by that, you look for a basic social process. So what's actually happening among two different people with diverse backgrounds. And I studied the transition of product development process towards manufacturing. And what are the peopling from the development side actually collaborating, and how are they collaborating with the people from the manufacturing side, the operational processes. Basically, it's also the transition from explorative activities, as it is mentioned in the literature, towards the exploitative activities within the organization, between search and efficiency. So the innovative behavior in this multidisciplinary settings was what I'm focusing on. Basically, you could say that I already started to connect the social sciences to the engineering sciences. And I realized that that was basically missing. If you look at the social sciences, then there is not enough literature that really describes what actually happening inside organizations. After that, I did a lot of research and a lot of education and collaboration with industry, as also sub-mentioned. And now I'm a full professor in this domain, and I look at it from the entrepreneurial perspective, entrepreneurial behavior. So I work at the School of Industrial Design Engineering, and I'm also part of the Delft Center for Entrepreneurship. To summarize, you could say that my focus is transdisciplinary because I need to connect many disciplines from the literature in order to make sense of what I see in practice while people are acting and interacting during the innovation activities. So I became a little bit of a social scientist, although it took me some years to be really sure of that I could say that I'm a social scientist, and I'm still not really sure. But I do look with an engineering lens towards the practice, try to make better theory. So what does society need? I didn't start from how we could innovate our engineering educational programs, but I started from the other side, from the needs in society. Basically, you could say that all the global warming and all the sustainability elements and environmental stuff is going on, but also health stuff is going on that is really asking for a different way of innovating. We cannot continue the way that we were doing that. You could say that this is a societal challenge, and some people frame it as a governmental challenge, but I think it's also institutional and industrial. And I even go further. It's not just a technology challenge in that sense, because we might know the technologies already, but then we don't know how to implement them or how to get traction in the large size of the government, of the society. But I also see it as an educational challenge. So I think it's a joint responsibility and a joint challenge that we should really work on this. And for longer term, you can say, well, we have to change the world as it is, but we can also change students and the educational program. So that's my start. And to give another example, this is the Boeing parking lot. And all this parking lot, you see all these Boeing 737 MAX that were grounded during more than 1 year, almost 2 years, because of the 2 crashes that occurred just before that. And so the parking lot is there. Oh, now I have to click here. This is the engine from the Boeing 737 MAX from the Ethiopian Airways, just 6 minutes after the takeoff. And it was a brand new plane. It was 4 months old and experienced pilot, etc. But then Boeing started to say, well, it's a pilot fault. And well, you could say that's the first thing to react to something like that. And then they say it's an engineering fault, a manager's fault. They even said in between those lines, they also said that it was Ethiopian Airways' fault because they have a bad reputation, or they had a bad reputation in maintenance of airplanes. But that's basically the choice that Boeing took to do that first. But I think it's also shareholders that push Boeing across the limits of safe design and engineering of new planes to be fast on the market and in a competitive setting with Airbus. But again, I think it's an educator's fault, maybe not, but at least it's something that we should focus on, because all these are multi-causality. There's not one reason, one cause, one root cause. And if it is there, then it is too hard to tackle in that sense. So you could say that the whole system needs to be addressed in that sense. So I think for the case of Boeing and maybe some other companies, it's a social system crash. And that is a joint responsibility of everybody involved. Okay, so one of my former PhD students, he focused on the innovation of control complex objects like these kind of ships that you see in the image here, but also drill ships and pipe laying vessels and these kind of things. And he took a social technical approach. And one of his propositions was that when he defended his thesis a couple of years ago, that the complexity of ship design is not only determined by the technical dimension, but at least equally as much, if even not more, by the social dimension. And that's what we don't address in our educational programs. But how to get it in? You cannot just take a book from the shelves from the social sciences and say, hey, you have to study this. You have to make it contextual for the engineering educational program. So that's what I focus on. So the technology development is really something as building a new plane or developing a new plane is a large array of different disciplines, and not just engineering disciplines, but many other disciplines as well, and also at different levels of education. So it's a complex situation, and you could say that sort of paraphrasing Larry Bucciarelli, that made this remark about design. He said design is negotiation among disciplines, but I think technological innovating is evenly negotiation among disciplines. But that's not what we educate our students for. So we don't educate them, we tell them basically nothing about the socio-interactive behavior. We might give them some teamwork and they learn on the go a bit about collaborating with their peers, but how much theory can we teach them about that? And that's only teams. And in organizations and looking at large objects, then it's not a team. Then there might be thousands of people or thousands of disciplines and maybe also organizations involved, and that makes it very complex. So you have to understand something about this social interactive dimension, so to say. Just take a little picture to clarify what I mean by that. You could say that on the bottom you see intradisciplinary, multidisciplinary, interdisciplinary, going up and then towards transdisciplinary. All these disciplines have their own ways of thinking and acting and language, lingo. You could say that if you are innovating within your own discipline, intradisciplinary innovating, that's very local. You don't affect the others, and that's okay. And that happens every day all over the place, you could say. Then you get something like steady state kind of innovation. You have a little bit of involvement with other disciplines, but you stay largely within the system that you're in. And then you get interdisciplinary innovation, which is sustaining the business situation, sustaining innovation. So the company stays there as it is, it's same competitive ballpark and not really changing a lot. But there must be some kind of, let's say, interdisciplinary interactions, collaborations that might change the way that we work within the discipline. So it might affect that. And what we're talking about here is that we are talking about entrepreneurial innovation. And entrepreneurial innovation is basically, you have to mix all the disciplines that are there. I learned that from looking at startups. When you look at startups, there is no discipline at all. There is one go, they want to build this company. At the early stages of this company, they typically start at the top of this image and then work slowly down towards they get a bureaucratic organization at the bottom, you could say, over many years maybe. But in the entrepreneurial settings of startups, they have not devised yet who will be doing what. But there might be a preference of the startup team that one is more easy with numbers and the other one is more easy with talking to potential clients or investors or these kind of things. And these might become disciplines and departments later on. So they basically move to them downward. But the trouble is that if you are very well organized in your organization and you have everything set in an exploitative fashion, then if you need to innovate beyond the borders of your disciplines, then it becomes very difficult because you have to challenge all the assumptions that are in there, but assumptions are most of the time are very hidden. Okay, so framing this challenge by decompositions, because it's a very complex challenge, and I hope to, that's where I am now in my development of my own understanding of what we're talking about, is this. So we can sort of decompose the situation in two perspectives. I'm going to explain those later. So you can decompose the situation in two perspectives. You can decompose the content in its logical state. You get two different states. And we can decompose the social system into four behaviors. Okay, so let me take you in there. So let's first decompose the situation. Any situation in an organization that is sort of a little bit moving beyond the regular situation, is deviating a bit, then that is the situation as given, you could say. But if you address it, do you address it as the situation is given, or do you think about this particular situation and move it towards a different way of approaching it, and do versus and then move towards the situation as taken, which might be different than the given situation. Basically, you do elaborate it, you investigate it, you do start an inquiry to understand what's really happening. That brings us in the world of sense making, as brought by Carl Weick, for instance, from the organizational literature. So sense making about the given situation brings you maybe to take the situation in a totally different sense to approach it. To give an example here is that even in the same example of the Boeing 737 MAX, before the crashes, there were some people that were warning against the situation. They were saying, we are moving too fast, we have no control on all the things that we regularly do with other planes. So basically, it was a sort of a whistleblowing. And you have to realize that if people stick out their neck as a whistleblower, then really that is a challenging situation. Like this one, he was put aside by the company management. They just moved on because they were under so large pressure by their clients on one side, but also the shareholders on the other side. And that was all caused by the fact that Airbus had already earlier introduced a similar kind of plane, the A320neo, doing the same trick, refurbishing it with a better engine, more fuel efficient. And that was also Boeing said, well, we have to do that as well. But then they took a plane which is 20 years older in terms of design as the Airbus A320, because the 737 was from the 60s and the other one was from the 80s. Well, anyway, that's what happens, and that's the situation as given or as taken. What should a company do? And basically, it's very difficult to move out of that. So what do you do with your weak signals and warnings and concerns? And I think that is what engineers also need to work with and know how to handle a situation that is sort of an anomaly or a warning or something like that, or even just a concern. They need to be open. It needs to be an open culture in the organization that you can talk about that. Okay, so let's decompose the content. This is a core element. It's based on CK theory from Armand Achuel and Benoît Weil and Pascal Lemasson. And it's about the logical state of the content that we talk about. It is a decidable content. We can say about something about it, and it's an undecidable content. Let me show the very roots of this picture, of this work by them. So you could say there's a concept space and there is a knowledge space. In the concept space, there is no logical status about what we are talking about. So it's undecidable. We cannot say whether it's true. We cannot say whether it's untrue. On the other side, we have a clear situation that we can talk about it. It's true, it works, or it's untrue, it doesn't work. And even if it doesn't work, it's also knowledge, you could say. So the no logical state, the world outside the box. What if, for instance, we don't know. That could also relate to the warnings that I just mentioned. We don't know whether it will be a problem. We don't know if the planes will come down. We are just wondering about it. So we cannot say whether it's false or true. And on the other side, we have the false and good answers. And that is a very interesting way of looking at the world. Although it seems very obvious at the beginning, at the face value. And Sub and I gave a presentation in Paris because Armand and Benoit are from École de Mines in Paris. We give a presentation about this is who can be against it. But then we started playing with it, and I will come to that in a second. So there are two different mindsets, you could say. There is a design space in the unknown, wicked problems and ambiguity and uncertainty. And at my School of Industrial Design Engineering, that's basically what we try to teach our students, that they are sort of moving into this area where they have no grips on anything, and they have to develop their own rationality on the ideas that they get along the way. And so it's a diverging creativity. You're opening up the space into new areas of solution. And it's reflective behavior, Donald Schoen, reflective practitioner kind of thing. On the other side, we have the engineering space. I really took them apart. It's my perspective and my filling in of this. Engineers are like well-defined problems. They work with a validated knowledge base. And they know the risks. If they make calculations about a new bridge, then they know how to handle that. They also don't know what not to do. So they have a lot of knowledge about the things that they're working on. Basically, you could say it's a sort of a converging kind of creativity. And to in the extreme, it's more rational problem solving as opposed to the reflective problem addressing or reflective behavior from Donald Schoen. Okay, so the way that we played with it is, first of all, I made it a continuum. I think it is important that we can see on the very far sides of the continuum, it's either totally undecidable or it is on the other side very totally decidable. And there is this continuum. And we might not be having any quarrels about the fact that it's on the very far left or very far right side, but we do have quarrels and social interactive challenges at the moment that we are talking about things that are closer to the middle, and then it becomes very situational. So one person might say it is true, and the other one might not say it's true, based on their own conviction. Just to give a little example, when we, in March 2020, we entered the COVID situation, and was it science that we needed help of, or was it something else? Our Prime Minister, Mark Rutte, said to the population, we sail on site. We have to sail on site. We don't know. So we have to move day by day, meter by meter, or whatever it is, but we have to move slowly forward and see if we get more understanding of what's actually happening around us. But at the same time, you got a call from a lot of people in the society to say, well, science, help us, because you are science, you know it. I mean, you have validated knowledge, so you know exactly what's going on. And of course, leaning only on science was also not really the situation. And we experienced as a 2 years, let's say, C-space kind of behavior, because we couldn't say whether mouth caps were working, yes or no, or the distance of 2.5 meters or 3 meters apart. There was no validated knowledge at all. So we had to sail on side, basically, you could say. Okay, so the difficulty is here that breaking free from your knowledge base, because then it makes you moving out of your control zone, your comfort zone, I mean. So moving out of your comfort zone is, for a lot of people, very difficult. For designers, they have their comfort zone on both sides of this picture. We train them on the left side, and of course, as a human being, they might have also feeling comfort by the knowledge that they have learned on the high school. Then the interactions are very challenging from people that are sitting on both sides of this division. Breaking free, but also bringing it back into. If we're really innovating, then we have to bring in new stuff in an existing organized world. And that is difficult because you have to create space for that. That is for startups entering the market and conquer their own domain, their own field, their own customer base, but also for new knowledge about technology in existing validated frames of understanding. So most critical, but also very challenging. And I find them very fascinating to think about these kind of things. Okay, let's move on. So let's show what happens if innovating. I think that innovating should move like this. Really move into the C space, the unknown area, inquire there. It's ambiguous, it's undecidable. You don't know whether it's going to work. And when you start moving back, then first you move beyond the constraints of the existing box, so to say. But nobody has ever seen the box. So you don't know when you're moving outside the box, but you only know that you're moving out of your comfort zone. You're moving out of the validated knowledge base, you could say. Okay, and then bringing the concepts back into the reality, basically you build new rationality, you build new knowledge, new technology, you could say. And you have to integrate that. And integrating is a design activity in itself. And so I think that that's something that we don't really teach to students, but in the end, you have the new box, and we are educating the existing box. Just a little example to show what I mean. There were these guys, young guys from the Delft University that realized that maintenance of windmills that are sitting out at sea, they are seabed based, so they're not moving at all. And then you need to get people on the windmill to do the maintenance. And the ship is moving, of course, in all these 6 degrees, back and forth, up and down, weaving, hemping, shaping, whatever the words are for that. And they came up with a sort of inverted steward platform, which you see on this picture. And steward platforms were used for how to train pilots. You understand what I mean? So the pilots are sitting in a flight mimicking machine, and then they learn how to fly, and the thing is moving in 6 degrees. They turned it upside down. They said, well, normally the flight simulator, that's the word, flight simulator is standing on solid ground and moves above it. And now we have to do the other way. It moves under, and we need to make it firm at the top. And basically that worked. So they have a big company now. They're all over the world. They are doing this kind of things, that they have this platform called Ampleman installed on an existing ship, and then transport the people from also oil rigs and these kind of things. Anyway, they needed to have a PhD to develop the new technological knowledge. So there was a PhD process involved. And they built a startup, so the entrepreneurial behavior. And they moved into the C space, so the design. So my chair for my professorship is called Entrepreneurial Engineering by Design. So basically you see it all in this example. Okay, let's move on. But far too often, patchwork innovation happens. So we don't move into the C space too much, maybe only on the fringes, that we are not sure that the kind of things that we develop will also result in the kind of business that we envision. So we only move a little bit in there, but technology-wise, we might not do it at all. Not too much. Of course, it happens, but much maybe by startups and maybe by coincidence, but it's often a hard way to move. So because we're missing all kinds of things. So therefore, what we actually missing is the social dimension. So let's decompose the social dimension into 4, I think, essential dynamic behaviors. And with the word of dynamic, I mean, it's beyond the organizational routines. It's not static. It's not doing what we did yesterday. It's not interacting the way that we interacted yesterday. It's a different way. Let's start with entrepreneurial. Looking at startups, what they're basically actually do is that they really try to convince all kinds of people to get a buy-in, to finance the things that they do. The first clients as a launching customer, will you try this product out? And I give you a little discount. But then on the other way, you help me with understanding how it works and for you. And so this entrepreneurial behavior is very much sticking out your neck and building a social network that accepts the new idea that you were thinking of as a team or as a set of entrepreneurs. This is similarly in organizations. People stick out their neck, they have ideas, whistleblowing, they have ideas and they are accepted or not. And but this is some similar kind of behavior. Then we have innovative behavior. Basically, that's content focused. So you're developing the new content, and the new content is by prototyping and working on it, etc. And at the end, you have the new. And if you differentiate this innovative behavior, there is this designerly behavior, is the creativity in the unknown, in the C space, as I mentioned, and the creativity in the known as engineerly behavior. And you could say that both are very much needed, but in the real innovation process that goes beyond the box, you first need to sort of have an inquiry going on in the unknown space. So the diverging kind of creativity that ends up with an integrating this conceptual thought into a proposition. Of course, you still don't know whether it's still working on it, so on the left side, but you have to work on it. And then you can say, well, towards the structural as the engineerly way of working together with a lot of people, because it's social interactive, what I'm talking about here, is robustinizing this proposition. You add your knowledge to it, you make your calculations, you also, making a contract with suppliers is also a sort of an engineering kind of an activity. Using existing knowledge of how to make sure that you have a robust contract for your suppliers. So these are the four essential dynamic behaviors, and we're teaching only one. We're teaching the engineerly. The engineerly is the one that we are teaching in our educational programs. Okay, so here you could say this is what we presently teach, engineerly innovative behavior. But what we don't teach, the designerly innovative behavior. And maybe only on design schools they do it, but maybe without showing them the organizational settings and the organizational behavior that's related to it. So we don't teach that move towards this C space. And we also don't teach the entrepreneurial behavior, how to interact with people. And it's not just the fact that one person has an idea, needs to sell it to another one to get a buy-in. It's a two-way process. It could even be the person with the great ideas could also need to sort of learn to listen to other people. So it's a social process that one person is not just one person need to convince other ones. It's a collaborative process. You need to do it together. And therefore we need to teach that. You don't need to be creative in order to go along with creative ideas. So for instance, go back to this first thing that I made, the decomposition of the situation, whether it's as given or as taken. And what you obviously dominantly see in practice is that you see that it is taken into the case space. So we neglect and we move on, or we solve it with the existing knowledge that we have. Sort of a patchwork way of, there's a little problem, we repair it and we go on. But we could also do it as taken in the other side, and we see it as a doubtful situation. So what is happening? Actually, it was not predicted that this moment happened or the signal came to us. So what is there? So basically, you have to start a design inquiry in order to make sure that you start understanding what's actually happening around you. And there is a lot of tensions there. You have your key performance indicators from the existing world, the existing business situation and processes that your organizational routines and processes that you're involved in. And then you feel the tension to move to the intuition area. That is not a single person process. It needs to be part of the discourse of the organization, it needs to be part of the culture. So these four processes needs to be understood in the cultural dimension of the organization. So also by engineers. So what is the challenge then? How to educate if we want to take this into to our educational program. Okay, just the picture that I started out with is I placed it on this CK space situation. So basically, you could say that on the left side, you have this transdisciplinary or even non-disciplinary kind of things for a startup, because they don't have disciplines. They only have preferences as a startup people. They might also have disciplines, of course, but that's a different thing. But basically, if we innovate only in the case space, then it becomes very difficult to address all the grand challenges that we have. So the indirect target group that we have, you could say, is that the students. That's the indirect one, because I'm talking about train the trainer program in a minute. We have the outliers like Elon Musk and Steve Jobs. Basically, you don't want to have them in the class. They teach themselves. They are learning machines themselves, because they know what to need to know. They know what to need to learn, etc. So these are the outliners. But then we have a very interesting group of people that have sort of a higher entrepreneurial tendency, a natural tendency as a person, and they really want to sort of say, oh, maybe I do a startup and maybe not, but if I work in an organization, then I might have this tendency towards being creative, come up with all kind of new ideas all the time. But then we have a lot of innovating engineers that need to collaborate with them. As I mentioned, with the two-sided situation of talking about new ideas, you also need everybody else. So you need to collaborate with people that have less ideas or lowly entrepreneurial, because they help you to stay on the chessboard, so to say, or even they help you to define the chessboard. So that's the kind of entrepreneurial engineers that we need. So it's often misunderstood if we say we are going to educate the entrepreneurial engineer. They say, well, that's about startups, it's about money, etc. And then I say, no, it's not about startups and money, it's about behavior. And behavior in a context. And that's basically what I really want to focus on. And so the aim is to bring all engineering students a little bit of that engineering domain, entrepreneurial engineering perspective. Just give them some theory, give them some understanding that it is there, that if they are not an entrepreneurial, that it is equally important to have a prominent position into an entrepreneurial endeavor, etc. So that's focus. And then we have developed, together with people from other 4 technical universities, that is the 4 TU sitting on the bottom. Oh, sorry. CEE stands for Center of Engineering Education. So we have our 4 technical universities in the Netherlands are united in this federation. Educating the entrepreneurial engineer, but changing the name of that might be that we change it towards transdisciplinary innovation. So you have to move along across all the disciplines that are there, and not just engineering disciplines, as I mentioned earlier. These are the 4 technical universities, and some of you might know them. Maybe you don't know Wageningen, which is the agricultural technical university, and the other 3, Delft, Twente, and Eindhoven, are pretty much similar. However, Delft is the oldest one by far, and the greatest, the largest one. I'm not so sure about the greatest, but that's not interesting. So what knowledge do we have to address this need? Slowly moving towards the end. The problem is that you see at the bottom the domain of practice, and at the top you see the domain of science. And what you see is that in practice, the things that we want to teach our students are happening every day. So it's united there. They don't make any divisions in these kind of theories or sciences behind it. But it is divided in theory. And that basically is was my challenge in order to bring that in there. So based on all the research that I did over the many years together with my colleagues, we built some kind of a theoretical framework about entrepreneurial engineering. It's not complete, it's not validated, it is there, and it provides a very interesting perspective. So what are we going to do with that? Again, you see the same picture, domain of practice and the domain of science. And then on top, you see the engineering disciplines that we have at all these technical universities. And we have the engineering students. And the disciplines are sort of teaching the knowledge that they have to the students, and the students bring it to the practice. And now what we want to do is that we bring this theoretical framework in between. And just to ask our teachers to develop maybe a full course or small modules or something like that, that sort of addresses this totally overlooked dimension of technological innovation that we are talking about here. One of the ideas is a TJOs. As you see on the right, you see TJO, as I call it, and that is standing for a technological innovation journey. The idea is that behind this technological innovation journey as a teaching educational element is that...
3 to 5 minutes.
Yeah, even less maybe. Perfect. The idea is that all the knowledge that we are teaching now to our students is the result of the technological innovation process of the past. So it might be that we started 2 centuries ago with understanding how to build dikes in the Netherlands and how to defend us against the sea. But now we have, over the many years and decades and centuries maybe, we have a validated body of knowledge. And this body of knowledge is what we teach. And that's great, of course. That's what we want our engineers to understand. But we don't teach the journey with all its richness. Of course, we can talk about an invention that was done by somebody at some point in time. That's a breakthrough technology-wise. But you could also use this kind of historical biography of the technology by also including the behaviors and mindset and organizations and patent wars that went on to build this new technology. There's not just one person doing it all. It's always a collaboration of organizations and people and breakthroughs and surprises that happen. So that could be, if teachers are sort of taking that into account, this journey, and frame the technological innovation journey in the knowledge that we teach them about the 4 dimensions and social behavior, etc., then we might have this. So what do we have as a structure of the TTT program? Currently, we are building basic modules online about innovation. So we focus on innovation in a different perspective as the object only, because we take a behavioral perspective. And we are building basic modules for that online, so everybody can follow that, the students as well as the teachers. And then we have the fishbowl sessions, as I call them, that we teach the theory that was sort of sitting in the middle, that I showed you a minute ago. They need to absorb that, and that used as a basis for designing their own module for education. And then finally, they design, we coach them in that, and then they refine it. Basically, if within one master program, only 2 courses or even only 1 course does this, then we already achieve our goal. So first a taste online, then theorize by the fishbowl sessions, then you tackle the situation and then you start teaching it. That's the idea. Well, this is the time commitment that we talk about, but that's not really important for now. Okay, so that's really now, because in about 10 minutes, I will start one of those fishbowl sessions to a couple of teachers that are involved in the pilot. So basically, that is what we're doing now, and that's my talk. Thank you very much.
Thank you, Frido, very much for a really elaborate and focused talk on your work and research. Now I will open it up for questions, as there are only a few people. Mr. Raman, please go ahead.
Thank you, Dr. Subramaniam. I had a question for you, Professor. It's the question of the culture that you talked of, that the entrepreneurs must be educated in. And I appreciate that, but what does one do if there are organizations that have built silos within themselves, where you have uh, peculiar cultures which make the silos objectives different from that of the organization? And when you brought up this discussion on the Boeing planes that crashed and how they were trying to blame it on a series of people in turn, it reminded me of the Challenger disaster many years ago, when Professor Feynman found that having a chat in the canteen with the engineers in the silo was much more illuminating than the detailed discussions during the Roger Commission. And in fact, it turned out in the end that it was the rubber O-rings that were causing this problem. Things that cost collectively maybe $100 in a spacecraft costing several hundred million.
Yeah.
So the silos had got so powerful that they simply neglected their own internal viewpoints that were coming up. How does one tackle that?
Yeah, the utopian idea that I have is that if people do understand that there are different ways of looking at the situation that pops up at some point in time, that we know that we are open to go to another form of interacting. And obviously that's not in routines of businesses. They move on. Not long ago, I gave a talk about creativity in the belly of the beast. And that was basically focused on the belly of the beast, the belly of your organizational processes are parasympathetic, they are autonomous, they move on without anything. And how to find the moment and stop and think about what's actually happening. It should be inside the organization as part of the culture. And I think the best thing to do that is to make explicit how to do that, these kind of processes, what kind of interactions you need, without really with the aim to disturb things, but to make sense of what's happening around you. And then come to the solution that it was only $100 that they needed to get in there, and maybe a lot of engineering work in order to make sure that it also relates to the system. But basically it would have maybe taken only 1 month extra in the development of the plane instead of 2 years of the grounding. So it's a utopian perspective. I think that we should learn that because we don't know how to learn it. Kids do know it, by the way. Before they go to school, they know how to play and how to interact with each other. So it is in our natural behavior, and our school system sort of kicked it out, more or less. Is that okay for you?
I think the business of schools is a very interesting point. It's kids. We should learn from the kids.
Exactly. Yeah.
Thank you.
You're welcome.
So, hello, Frido. I think an excellent talk. I can relate to a lot of points that you have made. I have one specific question is about the train the trainers model, right? My own experience has been that if you look at students in their early stages, like a freshman or a second year engineering, they may not have the knowledge base, but they may be comfortable jumping into a concept space. They may not be able to explore the concept space sufficiently. That's the student's situation. But if you look at a faculty, they are typically in the knowledge space.
Exactly.
Right. Now, if you apply a train the trainer model, we may be spending a lot of time in getting a faculty to become comfortable moving into the C space, while there is an opportunity to directly work with the students in the C space and explore it. So my own thinking has been that why not start the process with the C space and with students, and then have faculty as co-mentors in this process, rather than directly trying to train them. What's your view on that?
I would love that. The problem is that a lot of teachers are not very feeling comfortable with moving into the C space because they build their own self-esteem on the fact that they are very knowledgeable on the things that they're going to teach. So it needs to some kind of a training program. It could be that you even include it in the university teaching qualifications program as a sort of basic module that all teachers go through and learn that there is this C-space kind of world that they could take their students into if they are feeling comfortable in doing that. So I think it could work, sure. Yeah. but then also related to the theoretical practice, the theoretical domain, to make sure that it's not just fun. Is that okay, Sudhir?
Yep.
Thank you.
Frido, I really enjoyed your talk. Thank you so much.
You're welcome.
Your talk, of course, was focused on educational environment, which is great. I mean, that's fine. If I understand it right, Vijay Raman's question was focused on existing organizations.
Exactly.
And the challenge of getting people in the existing organizations to retrain them, redirect them in the way that you're talking about educating people in the universities. Because while university re-education is very important, as you rightly point out, vast numbers of engineers are working in those siloed environments.
Yeah.
Their mindset is already frozen into that. Has there been some thinking about what to do about those 90 or 95%?
That is, Sariam, thank you for your observation and question. I think it is a huge
Vijay, I didn't mean to put words in your mouth, but I hope that's what you're referring to.
Sorry?
Absolutely. Absolutely. That's exactly what I had in mind.
Yeah. So the thing is that what I do is that I also collaborate with industry. And for instance, in the class that I'm teaching now, we have 80 students and we have 16 professionals, innovation professionals from industry. And they have an organizational challenge. That's where the students work on. And then in the end, we give them a masterclass on the topics that I've been just discussing. And then they realize that not only they need to know that, but also their bosses and also their peers. So it's some kind of it needs to proliferate, because I also do some consulting with some ministries in the Netherlands, and they are sort of straddled. Is that we were thinking about innovation as an object, and we have no idea about talking about innovation as a process or a human activity, socio-interactive activity. So the installed base of indeed maybe 95% or even more has no idea about this.
Yeah.
And it's a long way. But now I'm talking to India, so and India is a large country, isn't it?
Yeah. Well,
good luck to you.
Yeah, the thing is this, right? The point I think Frido is making is there are two parts to the education: educating the industrial people by involving them in these courses, as well as educating the students. It's a dual purposed effort in the education space. And I think that is a very critical part to overcome some of what Mr. Raman was talking about.
Yeah. So we're also focusing on developing, let's say, postmaster or executive education around this.
Yeah. Well, you have to expand into the 95% in due course.
Yeah. I need a little bit help there.
Very interesting.
Thank you, but I need a little bit help there. And Paris, they are doing it, by the way. So they get a lot of people from industry that starts to understand what we're talking about, or what they are talking about.
We'll get them to give a talk too soon.
Yeah.
Thank you, Frido. Very interesting approach. I especially liked the one where you go from the interdisciplinary to the interdisciplinary, because I think as faculty, we move up like that. You know, we eventually probably get to the, but in the entrepreneurial journey, you say that it's a top-down approach. So I just found that interesting, because as faculty, we tend to sort of operate in silos and then slowly start collaborating and becoming, going to the top of that.
Yeah.
So that was interesting.
Okay, thank you.
Can I ask another question?
Sure.
It is becoming increasingly popular in universities to assess faculty on the basis of their research publications.
Mm-hmm.
Do you think this, or to what extent does this well-intended attempt to try to get faculty to innovate and in research space ends up defeating that purpose by getting them deeper and deeper into their own individual disciplines and become resistant to the multi-cross disciplinary work or thinking going into new concept spaces?
Yeah, thank you, Shyam. I think that's a great question, because that is challenging. If you really want to pay more attention to the kind of education that you do, then you have to let go the amount of publications that you write or the things that you do on the other side. But I guess that this era of valuing publications and citations only as a means of valuing the quality of academic personnel is coming to an end. And I think that all universities are sort of founded because of that they need to bring knowledge to society by students. Because society is never reading our papers. There's only our peers are reading them. So the only way to get the knowledge that we develop as academics into society is by bringing that through students. And the real problem there is that I think that there needs to be a sort of a little bit of a paradigm shift, which in the Netherlands is taking place, by the way. So we are going to value not only the citations and the amount of the Hershey Index and all these kind of things and the papers, but also the kind of things that you do in collaboration with industry and the things that you do in with innovating your educational part. Not just the course that you give, but maybe also the programs and the larger context of it, because that's also academic. So yeah, it is, but it also a little bit utopian maybe, but it is changing. That is changing already. I don't need to ring the bell.
That's
at
great.
least in the Netherlands.
Yeah. Okay. Thank you so much, Frido. Really, it was a lovely lecture.
Well, thank you for the opportunity, Sub and others, because I really like to prepare it. And I came to some new insights myself while preparing it. So always good.
Thank you.